All right. Everybody doing good today? You all ready for fiesta and all that stuff? Holidays? Yeah? Anybody going to any fiesta events? No?
Yep.
What are you going to go do?
Nyosa.
Nyosa?
Yeah, we already did the taste.
Okay. What night are you going to Nyosa?
Probably Thursday.
Thursday, college night. Is it still college night? Is it still college night on Thursday? Okay. Okay, cool. So we have, first thing, grades. So I've updated all the grades. Did y'all notice that? Anyone notice that? Yep. Okay, is that good or was it, well. So our next test is, May 1st. So we still have a little bit of time. But this Friday is the drop date, like I've mentioned already. So all your stuff is here. I'll try and get that back to you. I might just pass it around. You can kind of fumble through it and get all your stuff out of there. If you have any questions over any of those grades, just get with me. Remember, you can go into Canvas and you can put in like sample grades, I believe, right? You can do that for everything you don't have grades for, right? So you could go in there and like give yourself like the exam for, you could like give yourself whatever, a 75 or an 80, go into the final, give yourself a grade, and it'll tell you where you'd wind up. So if you're curious, like, can I still pass or can I still get a B, just go mess with the grades and talk to me if you have any questions. Okay, so last class we were talking about polynomial functions, right? And I told you that I wasn't real happy with the way our packet does the polynomials. So let's continue with what we were doing last time. And I thought what I would do, I'm going to put this over here. Let's put that table that we had created last time so we can reference it if we need it, when we need it. What were the things that I had here? So was it degree right here? Put degree here. And over here was the leading coefficient. So in terms of the degree, when we were talking about polynomials, what is it that we're interested in?
Degree.
For degree, is it even or odd, or is it positive or negative? What are we most interested in?
Even on.
That's right. So even or odd. All right, so even or odd. And then when it comes to the leading coefficient, we were interested in the positive or negative, right? So positive or negative were two different things we would look at. If it was even and positive, it went up, up, question mark. If it was even and negative, it went down, down, question mark in the middle, and then down, up, question, and then up, down, question, right? Okay, so that's our table. This was called the leading coefficient test, right? So what we learned, I guess, last time is that we're going to look at a polynomial function. We're going to figure out what it's doing at the ends. And then to fill in the middle, we find all the little x-intercepts. And the only example I gave you was one where I gave it to you, it was already factored. Remember that? And then we multiplied it all out, and that was kind of a pain in the butt. So let's start with another example. But this time we're going to use a shortcut, which I think you'll appreciate. So let's take x squared, x minus 3, and x plus 5. God, this thing's squeaky. Can you all hear that? Kind of annoying. See if these are less squeaky. All right, so the instructions here are for us to sketch this. All right, I want to sketch this. So the first thing we have to do, well, we first have to recognize it's a polynomial function. That's, I guess, the first thing we have to do. But once we know that we're looking at a polynomial function, we need to determine the left and right-hand behavior. All right? So this is where we have to multiply this out, right? Now, do you see how bad this would be? Just imagine taking this to the 4th power. That's x plus 5 times x plus 5 times x plus 5 times x plus 5, doing all that multiplication, right? Wouldn't that be a pain? And then after you do that, you have to multiply that by x minus 3, and then x squared, and it would take us forever, wouldn't it? So here's the shortcut. What we're going to do is we're going to look at these, and we're going to ignore any numbers that are being added or subtracted to the x within a parenthesis. So here, this piece right here is really kind of behaving like an x to the fourth. Do y'all see that? I mean, it's really x plus 5 to the fourth, but we're going to look at it as just being similar, not the same as, but similar to an x to the fourth. All right? Yeah? Okay. This one is really like x to what power? The what? 1, right? Because this is like x to the first power. This is like a first power up here, right? So this is really like an x to the first power. And then this one is really like what? Well, it is x squared, right? So we can say x squared. So the idea here is this. Let me see if I can convince you of why I'm doing this. Let's just say I wanted to torture you and actually have you multiply this out, which I wouldn't do, but okay. When you do these two together, what's that first term going to be? When you do this and all that stuff, what's that first term going to be? X squared, right? And then you have a bunch of crap in here, right? And then you got to multiply that by, let's do these two together. And when you do those two together, what would be your first term? X squared again, right? And then a bunch of crap in there. And then when you multiply those two together, the first multiplication you do is here to here, right? And what's that? What would x squared times x squared be? X to the fourth, right? So your first term would be x to the fourth, and then you would have a bunch of stuff here, right? But this would be the highest power of x, wouldn't it? The highest power you're going to get is x to the fourth. And so this whole thing expanded out, x to the fourth is the highest power you get. Does that make sense? This one, if you expand it out, which you can't expand it, the highest power you get is just x to the first power, and this is x squared. So if we put all three of these together, if I asked you to multiply those three together, what power would you have on x? So how do we do this? Add them, right? Add those numbers together. So 7. This is what we're going to use for the table. Okay, so we don't have to multiply it all out. That's what we will use over here. That will tell us our end behavior. So this is the shortcut. All right, does it kind of make sense where I'm getting this from? Just kind of like we're acting like if we did this, we know what would happen with that first term. Okay, so what can you tell me about the left and right end behavior of this function? What does the left side do? Or maybe I should ask you this. What's the degree of this? 7. And the leading coefficient is 1. Who said 7? Yeah, you said 7? Okay, I wasn't sure. Did you watch the video or no? Last class?
No, I looked it up.
Okay. All right, just want to make sure you're not, because I know you weren't here. So degree is 7, right? Leading coefficient is the number in front, like that. So now we go over here. Our degree is odd, right? That's what we're interested in. And then our leading coefficient here is positive. So our graph will do what? Down and up. Okay, so left side down, question mark, right side up. Okay, now we go get the x-intercepts. All right, so I'm going to draw, it's time to start drawing my graph. All right, so what are my x-intercepts? How do I find them? Set each of these equal to 0, right? Each of these factors have to be set equal to 0. So I have to, maybe I shouldn't have put my graph here. I'll do my graph somewhere else. I have to set x squared equal to 0. I have to set x minus 3 equal to 0. And I have to set x plus 5 to the 4th power equal to 0. Okay, so I'm separating each of these factors out. Okay, so tell me about this one. What is the only number that you can square and get 0? 0 itself. You all comfortable with that? The only number times itself that gives you 0 is 0. Okay, what about this one? This is just a little linear equation. What's the solution? X is 3. Okay, so you would just add 3 to both sides. Now this one, we don't have to worry about the fourth power. Not right now, not to figure out what x is. What x would have to be here to make this thing 0? Minus 5. Minus 5. Negative 5. Right? Are we okay with that? Just imagine if x is negative 5, negative 5 plus 5 would give you 0. 0 to the fourth power is 0. Okay, so these are our x-intercepts. How many of them do we have? 3? And now let's plot them on a number line. So let me see. I have 0, I'll put it here. I have 3, which is over here. And I have negative 5, which is somewhere over here. We know that when we graph this, the left side goes down, right? So from this point, it should go down. Don't do that yet, okay? But let's think through this. This should go down, right? And then this side should go up. The question was, what about the middle? In last class, we talked about it's either going to cross through or it's going to bounce off. Remember those two different scenarios? How do we determine whether or not it's crossing or bouncing? Multiplicity is odd. What's multiplicity, though? What are we talking about when we're looking at this? What's the multiplicity? The exponent on the factor. So let's look at this one. This one is x squared, right? That is an even number, right? That's even. This one, x minus 3, this was an odd number. And then this one was an even number, right? So what that tells me is that, let's see, where did x equals 0 come from? It came from here. That factor, x squared, had an even power. Even means, what do we do? An even multiplicity means you bounce. So we are going to bounce off at 0. 3 comes from here. This factor has an odd multiplicity. Odd multiplicity means cross. Here, negative 5 comes from this one, has an even multiplicity. Even means bounce. What do you think the biggest mistake is that I see with students in how they determine this crossing and bouncing? What do you think the biggest mistake is that I see?
Taking x against x. Like
See?
the 0 instead of...
Exactly. So like they'll look at this and say, oh, 0 is an even number, so I'm going to bounce. In this case, it would be correct, wouldn't it? But it would be the wrong way of doing it, but you'd get lucky. Look at this one right here. Negative 5 is actually an odd number. So you might think, oh, I'm going to cross. No, it has nothing to do with the actual x-intercept. It has to do with the power on the factor. That's your multiplicity. Okay? So make sure you understand the distinction between those two things. Where you cross, or sorry, where you touch the x-axis, and then whether or not you're bouncing or crossing there. All right, so let's try and draw this. At negative 5, what am I going to do? Bounce. So when I draw this, I know it has to go down, right? But when I come up to this, I want to bounce off. This is why in the beginning, remember I told you don't draw it yet? Like don't draw it, because look, if I draw this right now in the very beginning, then bouncing might be kind of weird because it might look more like a V instead of nice and curved. So I like to put it all together at the end. So I know that I'm going to go down on the left, but I'm going to bounce off at negative 5. So I'm just going to come up here and bounce off like that. Okay, now I have to get back to this point, don't I? So to get back to it, I'm going to just curve this thing back around. Why am I curving it? Why is it curved and not like straight, jagged lines? Polynomials are all curved, right? We talked about this in the very beginning, the properties. They're all curved and smooth. So I just need to come and turn back, and when I get to 0, what am I going to do here? I'm going to bounce again. So it's going to go like this. It's going to come up. It's going to bounce off. And then when I get to 3, right, here, I will cross through. And when I cross through, well, I'll wind up going up, which matches up with what I was supposed to do, right? If you get to the end and it says, let's say it said cross through here, but the leading coefficient test said it went down. What does that mean? Like what if it said cross through, but this told you you were supposed to go down? What should that be an indication of? Something's wrong. Okay, you've done something wrong, multiplicity's off, something is off, okay? Everything should go at the end and be nice and smooth and look right. So did you ask the question at the end of class about up and down? Who asked that? Was you? Okay, so everyone's going to have different looking answers, all right? You can have, like, let's say you drew yours like this. Okay, that answer would also be correct. Okay, both of these answers would be 100%. All right, how far you go down here is totally up to you. As long as it's smooth and curved, we're good. Same thing over here. You know, if you go down a little further, that's okay. If this just kind of arcs out like this, it's okay, as long as you have the main characteristics in place, which are left side down, right side up. Okay, the x-intercepts have to be correct. Everybody's graph between here and here better be down here. Everyone's graph between here and here should be down below. Everyone's graph over here should be above. Make sense? All right. So I think the question last class was, you know, how could we determine how low you go here, right? Like how far down do you go? And that's just something we do not discuss in this class, and that's actually what you do in a calculus class. My calculus class right now, we are doing this. We are finding what we call the local maximums and minimums of just an arbitrary function. But we do it for all functions in calculus, not just polynomials. We do it for any function you can think of. So, all right. Does this kind of all make sense? Okay, I'm going to do one more example, and then I'm going to let you do a couple, all right? And if you're comfortable with this, then good. Jeez, this stuff is hard to erase. Okay, here we go. So let's try this one. We're going to get a little tricky now. Yeah, let's just do that. So this is a polynomial function, and I want us to sketch it. So my first step is to figure out what the left and right hand behavior or end behavior is, right? What's the left side doing? What's the right side doing? So I want to be able to do this. So I need to identify the degree and the leading coefficient. So this is where I want you to use the shortcut. So let's identify each of the factors and talk about each one, what they kind of are behaving like. So what is this one behaving like? And this is the first time I've given you this one. It's a little tricky here. What do you think we're going to put for that? Just leave it? So do we want to put x there, or do we need to include the 3? So think about if we were to multiply all this out, right? If we were to multiply it all out, would the 3 come into play? Would the 3 have an impact on your leading coefficient? I mean, you would have to multiply this 3 through, wouldn't you? So that 3 should be included down here as what that's behaving like. So this one is pretty simple. It's behaving like itself. What is this one behaving like? This is a tricky one. It's really behaving like this thing squared. So when you square this, you get 4x squared. You square the 2 and the x. So this is behaving like 4x squared. Is this making sense? And then what is this one? Be real careful on this one. What's this one behaving like? Negative x? What do y'all think? So I switched the order on purpose just to confuse you, right? But the 4 is the part we ignore here. This is really behaving like x, but there's a negative, like a negative 1 in front if you like. So it's really behaving like a negative x. Follow or no? What was the example I had earlier, just before this one? Let's look at that one real quick again. What was it? It was x squared, x minus 3,
and then
x plus 5, and this one was squared also, right? Oh, this one's to the 4th. Okay, so let's run through this one again, just to, now that we've kind of seen a second example. This one was really like 1x squared, right? So we put x squared. This one was really like 1x. So we put x, right? This one was really like 1x to the 4th power. So what's 1x times itself? X to the 4th. So this is what we had, right? X to the 7th. But I intentionally gave you a problem where these were all 1s in front of them. And I also gave you a problem where there were no negatives. I wanted to wait to the second example before I did something like this. But see, we did the same thing here, but it was just a little easier. Now it's a little more complicated. We need the 3 and the x. We need the 2x, but we need to think about it being squared becomes 4x squared. We have negative 1x. Well, negative 1x is just negative x. Okay? So now, what would happen if I multiply all those out? What would be the number I would get in front? So 3 times 4 times negative 1, right? So negative 12. And then what would the power be? So x to the 4th power. Because you have x to the 1st, x to the 1st. So if you add up, 1 plus 2 plus 1, you get x to the 4th. So this is what this thing is behaving like. Negative 12 x to the 4th. So what is the degree of this?
4.
Degree is 4. And the leading coefficient is negative, right? So what does that tell me in my chart over there? What's happening with the left and right hand behavior? Left side down, right side down. So we're pulling off of this right here. We have an even degree, and we had a negative leading coefficient. So we're looking at that right there. Any questions? What happens if you mess up one of these things, and this is like you say x to the 3rd or x to the 5th? Like what happens to the final product at the end? It's all wrong, right? It's going to be incorrect. So there's very little room for error here, all right? We got to get everything perfect. All right, now what do? Find the x-intercepts. So for the x-intercepts, I'm going to set each of these factors equal to 0. 3x equal to 0. What's the next factor?
4x.
No, don't. These were only for the leading coefficient test. So we have to go back to these to find our x-intercepts. 2x minus 1 squared equal to 0. And then the last one is 4 minus x must be 0. All right, first one. Is it obvious on the first one? The only number times 3 that gives you 0 is 0? Or you could divide both sides by 3. You'd still get 0. The only way I can square a number to get 0 is if this is 0. So I'm just going to write down this. And now I'm going to solve for x. So move 1 over, right? Add 1 to both sides, divide by 2. So what should we get here? 1 comes over, divide by 2, 1/2, right? And then the last one, you can just add x to both sides if you want. And you get x is what? 4. So we have 3 x-intercepts again. What about the multiplicities on these? Am I bouncing or crossing on these?
So the first one you
Yeah, this one right here has a power of 1, doesn't it? And if 1 is an odd number, and if it's an odd number, I'm going to cross, right? So this is odd. This one is even. What about the last factor? It's a 1, so it's odd. So what's happening at this x-intercept? We have odd, so we are crossing. This x-intercept, even, so we are bouncing. And this one at 4, we're odd, so we are crossing. Now a number line. And once we have the number line, we set everything up and start drawing. So make sure you get everything on your number line in the correct order. 0, half, 4. Notice when I'm doing my number line, have y'all noticed that I'm not drawing like all the little tick marks for all the numbers? I'm just plotting the x-intercepts themselves. Don't bother yourself by having, don't come in here and put like, -1, 1. Like, don't worry about all that. Just get them in the correct order. We don't care about anything other than the fact that they are from left to right, they go up. All right? So those are them? Yes? And now we know that the two ends go down, right? So I'll start from here. If I'm going to go down, what happens at 0? I'm going to cross, right? So I'm going to be going down. When I come up through 0, I'm going to cross through. Okay, so I've crossed through the x-intercept. When I get to 1/2, I'm going to have to bounce off. So bounce. And then what happens at 4? I cross. And does that match up? I'm going to go way up just because I feel like it. And then I'm going to go down like that. Does that match up with what was supposed to happen with the end behavior? It does, right? Both ends go down, came up, cross through, bounce, cross. What do y'all think? Okay? On your exam, I'm going to give you just exactly like this. I'm going to give it to you factored, all right? So all you have to really be able to do is set each of these factors to 0, figure out the multiplicities, and then use this shortcut. You need to be able to do this shortcut to be able to figure out the left and right end behavior. So you ready to do a few on your own? Let's do that. I'm going to give you some, and what I'd like for you to do is go through and sketch each one of these, all right? Let's do this on a separate sheet of paper. I'd like to use this as a grade today. I don't think I'm going to collect it, but I am going to go by and check it, all right? I'll leave the leading coefficient test up here on the board for you. Here it comes. Okay, you ready? Here we go. It's gonna be a lot of problems. All right, so number 1, let's do f of x is x squared times x minus 3. Number 2, f of x is negative 2x times x plus 2 times x minus 2. 3, f of x equals negative 2. It'll be interesting to see what you do with this one. X plus 3 squared, x plus 1 squared. Number 4, I'll get out of the way in a second so you can write these down. Negative x squared, 2 minus x, x minus 4 cubed. We're going to do 2 more after this. You understand what you're supposed to do? Okay, you have the remainder of the class to finish this up. Help each other out.